Hi everyone, my name is Maggie and I'll be your host for today's webinar on test, training, and exercises for space professionals. Today's webinar will be delivered by Jim Fields. Jim joined AGI in 1996 and is currently the Chief Engineer for SEG, the Space Event Generator. We also have Ben on the line, an aerospace software engineer who's been with AGI for 2 years.
Hello. Yes, my name is Jim Fields, and as Maggie said, I've been with AGI for nearly 23 years. I've worked on a number of different products while I've been here, SDK and ODTK. I moved into the SSA realm, and then lately I've been focused in the TTX area, working on a product called SEG. And so today we're going to be talking about TTX, which is test, training, exercises for space professionals. And we're going to take a look at SEG, our Space Event Generator, and see how it can be used to support TTX. And if we have time, we're also going to look at some example scenarios. I'd like to show some cases where we're creating test or exercise data using time-shifted data that was created in some other time frame, and we're moving that ephemeris to compare against a current space object catalog and showing proxops from one of these objects going around another satellite. And we'll look at that interaction between SEG results and our other products, SDK and ODTK. And I'd like to show an example where we're looking at covariance results from coming from processing data that SEG is producing. So why should we care about space threats? This is the crux of the TTX. We all know that modern threats exist, whether they're obvious kinetic threats like direct descent, anti-satellite weapons, or more subtle tactics such as close proximity operations for intelligence or interference missions. And whether it is a compromise in secure communications or loss of service or even the loss of a platform, the security of modern cultures depends on space-based assets. And any of these losses would have a serious impact. So we have to understand these threats. Satellite operators have to be ready to detect and respond to potential threats in ways that have been practiced, while at the same time account for their own capabilities and limitations. And that takes a lot of training. We have to train better. The US outspends China 4-1 in space, and yet China is closing the performance gap. Clearly, our current tools and our approach to space training is insufficient. We need to find better ways to address these threats. In the age of Google and Amazon Prime, relying on 20-year-old software and multi-month training cycles in defense of critical assets is just unsatisfactory. A military cornerstone is train like you fight and fight like you train. And here at AGI, our former naval flight officers can attest that that is the way it's done in the air community. And they had the tools that they needed to do this. They trained in simulators that were functionally identical to the aircraft that they fought in. And this is where we need to get to in space. Based on our conversations across the market and with our customers, and based on the exercises we have supported, like Global Sentinel, we have identified two main challenges. First, our Air Force group commanders know that their training tools aren't perfect, and they're doing the best they can with the tools available. But it takes weeks to months of work to generate the data they need to run an exercise. And this extra time costs more and leads to lower readiness levels. If you're only training monthly instead of weekly, you can't stay current. It also means that you can't keep up with evolving threats. And slow tempos are not viable if you're trying to rapidly execute potential what-if scenarios, which is critical to tactics development. So frequent training is critical, but inhibited by and made costly with today's tools. The second significant challenge is accuracy. Any pilot walking into a simulator expects it to behave like the real aircraft, yet today's space data simulators use simplistic representations of the real thing. They often model only a portion of the catalog. Typical exercises include less than 100 objects. And that orbital data then gets passed around based on assumptions of persistent sensors and perfect orbit determination. Whereas in reality, operators have to deal with up to 20,000 background objects. Sensor data is noisy and sporadic, and the quality of OD solutions depends on the quality of the sensor data. And this kind of unrealistic training without real-world fidelity leads to poor preparedness. Just a sec. It was with these challenges in mind that we laid out a set of requirements for an ideal test training and exercise support tool. Any viable product would have to have sufficient scope and had to handle a majority of the regular threats and space events experienced today. It had to be realistic, employing full fidelity modeling. And it had to be quick and timely. Again, you can't model what-if scenarios and expect to make progress if you are waiting days or weeks between runs. We wanted to create a scenario, run it, learn from it, change it, and run it again within minutes. To accomplish this, it has to be highly automated. And of course, another issue is security. In the places where we work, security is a key concern. And finally, interoperability. Many of our customers have their own formats and their own tools as well. We envision ultimately an ecosystem of tools, each with different strengths. For example, one tool may excel at comms modeling, while another might allow detailed modeling of a low thrust trajectory. We wanted a tool to bring them all together into a coherent scenario, one that was built flexible enough to interact with the format of any of our customers. And now that we had a list of product requirements, we took the next step. We built a product named SEG, which is our space event generator. SEG has the following capabilities. It allows us to create multiple types of space events in all orbit regimes. It's able to create individual or linked sets of events, where linked events are where one space object is involved in a series of sequential events. For example, a space object can be launched, do maneuvers, enter into proximity operations around another satellite, then maneuver to go conjunct with another satellite. And SEG can solve for the intermediate maneuvers required to link these events together. Events are combined into scenarios, or another way of saying this is a scenario is a container for a set of events over a common time span. SEG outputs observations, ephemeris, and sensor in-views. And these OBS can then be fed into a flight dynamics or catalog processing system. Ephemeris can be viewed directly or may be downloaded for use in SDK. And SEG supports planning, training, testing, and exercises. And it also includes a user-friendly user interface as well as web services for integration. And later on, hopefully we'll have time to look through that user interface. So SEG meets the requirement for scope by offering 12 different space event types. We have reentry, proximity operations, deorbit, rendezvous, breakup, conjunction, deployment, maneuvers, orbital intercept, launch, and the next set of events coming up in our next release will be ASAT, direct descent, anti-satellite, and docking and separation. Again, SEG has user-friendly event workflows, and the gist is really that it allows an operator and not an astrodynamics expert to be able to create these accurate events and get results out. Some of the use cases that SEG supports are repeatable, tailorable operator procedure training. So if a conjunction is predicted, how do I respond? What steps do I take? Day in the life operations training can be, I follow a checklist of daily activities. I'm going to generate data, need to process it, get solutions, and feed them through a system. And SEG can be used to generate the data to provide that. Systems performance tests. I think I jumped a page there. For example, I could load observations in batches to test the orbit determination process, compared OD-generated ephemeris predictions against the simulated truth ephemeris that SEG is providing. Proof of concept studies, for example, adding sensors. If I add more sensors, what does that do to my ephemeris estimates? I can do simulated over live, where I'm adding simulated events to a historical catalog, or even adding new tracking data for an old event over historical observations. And we have exercise support, mission planning, and what-if tactics development. For example, when can I perform a maneuver that won't be detected by an optical sensor network? So our TTX workflow. So we start off by cloning an operational SSA database. And an SSA database is going to contain a set of catalog object states and a tracker system. So this is really geared towards someone who's maintaining a catalog of objects in space, where you have either a full SSN catalog of 15,000 objects, Or you might have your own set of objects that you're concerned about, that you're tracking or you're generating ephemeris for. But the main point of this is that SEG is using this database as its source of information for building scenarios and processing data. Once we have an SSA, once we have a database cloned, that through the user interface, the user builds a scenario, adds events to that scenario, and each event has a sensor cadence, and the sensor cadence, which we'll get into detail later, is used to define how much tracking data is going to be generated for each object involved per event. And the user can define a set of background catalogs, which can be used to just populate their scenario with objects to create as much noise or as much complexity in their scenario as they want. The next step is to run the scenario and generate observations and generate ephemeris for all of the objects within that scenario. And then once that data is stored, that data goes back onto this database, and that information can then be downloaded and shared with other tools. So this next graphic shows that data flow. This kind of golden orange color is the input data, where we have our sensor models. So we have sensor locations, measurement types, and biases. Those are coming from, typically defined by like an SSN network. And there's initialization data shown here at the bottom, where we have space object states and ephemeris that are coming from that catalog. And those are going to define what the initial states are for as many objects in space that we're concerned about. The user-defined event data is going to be input through our user interface or through the web services. And so that's something to note here, that we have a database that houses all of the data that's used in these scenarios. And between the user interface and that database are a set of services that are used to get data to and from the database. And these services retrieve and store data as well as kick off the data generation. And so the results, the observations, and the ephemeris are stored back in this database as well. So this is our landing page for our scenario, for our user interface. And this shows basically there are many scenarios here, as you can see. Each scenario has a name and a description, and each scenario has a time span. You'll see an analysis start and then an analysis stop. And many of these are around the same time span since they are using data from the database snap, which is providing space object catalog states at a particular time. On the right side, you will see the scenario details for the highlighted scenario up here. And there are buttons here to allow us to open up the scenario and view the events of the scenario, or go directly to the results or to generate output for this particular scenario. So we're going to return to this scenario shortly. So here's a sample event workflow where we're adding a conjunction event to a scenario. And this top of the screen is pretty much identical to all of the events in the scenario. We provide an event name, a description, some other data, and we're not going to get into that now. And one selects the event type. In this case, it's conjunction. And this second block of data is the conjunction data, which is based on this event type. And this chunk of data will change based on what type of event it is. So for a conjunction event, ultimately what we have is one object passing very closely to another object. And so the data that we have here, well, first of all, we select the primary object, the object being approached, or the target, as you will. And we define the time of closest approach for this conjunction. And then we have other data here that defines what the relative position should be between these two objects at that time of closest approach. There are a lot of inputs here, and we actually have tooltips and documentation for each of these inputs to describe exactly what they are. And down here at the bottom, we're defining the secondary object. This is the object that's going to be doing the conjunction, or the secondary, or the actor object. And we can either, there's one of two choices. There's this is a new simulated object, which means we're going to create an object that doesn't currently exist in the catalog. However, we could also take an existing catalog object and convert that into an actor so that it will be maneuvered so that it will wind up doing a conjunction with another object that's also in the catalog. And at the bottom of the page, which isn't quite shown here, one defines a sensor cadence, which is going to be used, again, to define how many observations are going to be generated for each of these objects over this event time span. And we will get to that again later on. But not then. All right. So our next slide is discussing what a catalog event is. A catalog event is a single event that groups together a set of objects which are propagated over the scenario duration. And these objects are going to share a common sensor cadence, which again defines how many observations are going to be generated per object over the duration of the scenario. We allow multiple catalog events in each scenario in order to support any grouping strategy that you might want. For example, you might want a catalog event that just has a certain number of geo-catalog objects that are tracked infrequently, or you might have another set of geo objects which are tracked very frequently. So you would want those in two different catalog events and define two different sensor cadences so that they can have the correct number of obs per object generated. You can also group these just by, I could have all my LEO satellites that are in the European Union in one catalog event, just to kind of partition things as you see fit. And there is no limit on the number of objects per catalog. Ultimately, this allows a fully realistic background catalog, and it allows a trainer or exercise conductor to adjust the difficulty of the scenario. Because if you're processing obs especially, the more obs you have coming into your system, the more you have to deal with obs association and orbit determination, trying to sort out which observations belong to which satellites. So our next slide, sensor cadence, we've mentioned it a few times. Each space event, ephemeris event, or catalog event can specify its own sensor cadence. And the sensor cadence defines how many observations are created per object per event. So what we do is, given the locations of the sensors and the constraints that the user can define via services on each sensor, we compute all available access intervals between each sensor and each space object. And from those, SEG will subselect a set of intervals to meet the cadence definitions and generate observations over those intervals. If you're familiar with the SSN tracking system, sensor cadences in SEG can be configured to match tasking codes in SSN. For instance, you could request that a geosatellite be tracked using one radar track every 2 days, 2 ground-based optical tracks per day, and 3 space-based optical tracks per day. So if it's possible to achieve it, SEG will provide a set of data as you have required, or as you have requested. And the ability to define individual cadences creates a more realistic training scenario versus assuming persistent sensor coverage, and allows the trainer direct control over the difficulty of the scenario. Plus, the ability to define the sensor model measurement models, the noise and the biases, allows us to model the realistic uncertainties that we talked about in the requirements. So if you're doing orbit determination especially, and you want to realistically model what those sensors can generate as far as measurements, SEG allows you to do that. So the architecture, we mentioned earlier that SEG uses services to communicate with an Oracle backend database. And the generation of scenario data is automatically distributed using SDK scalability. That kind of goes along in the background, and that's all run by services. We have a fully documented application programming interface, or API, which we'll see shortly. And we have support for both REST and SOAP services, and is completely automatable. We use a similar hierarchy to Systems Toolkit for scenarios, where SEG has a scenario which governs the simulation environment, and entities with events produce ephemeris based on the inputs, and is interoperable with SDK using visual data files, or VDF. And data produced from SEG can then be fed into your exercise engine of choice. So I imagine we might have some questions at this point. How are we doing?
We actually have a couple of questions.
Okay.
Are there modules or files that I need to download?
SEG is its own product. I believe that the SEG installation is going to have most of the files that you will need, at least to get you started. Some of the things, as any, if you're doing anything near real time, of course, you'd probably be wanting to download EOP and space weather as it's relevant to your time frame that you're working in.
Great. Another question is there a beta that SDK users can access to play around with?
I don't know about a beta version. We do have released versions. There's a 2.15 that has been released of SEG. I think I would direct them to a salesperson or one of our engineers to help them out.
Will do. And then how do you search the tracking ID?
How do I
search the tracking ID?
Search it? UI. Through the UI? Mm-hmm. Oh, yes. Oh, right. Exactly. Yeah, there. We might have a chance to actually demonstrate that. There is a grid that comes up, or there's a panel that comes up, and you can search all of your objects in your space catalog and find the, by tracking ID, which object you want to include in a scenario. If I'm understanding that question correctly.
I believe so. And then we'll save the rest for your Q&A section.
Okay. All right. All right, so let's do a couple demonstrations. How are we doing time-wise? Okay, we're doing quite well. The first thing I wanted to show was being able to generate test data, or perhaps even data for an exercise, where we have an engineer who has given us or created a scenario in SDK. And let me jump over to that. Bear with me just a moment. So it's taking just a second to render here. And I realize the graphics might be a little bit sluggish, so I'll try and see what our response looks like. Okay, so we have an engineer that created a launch profile where there's a launch object and two stages that are being dropped off. And the launch payload, which is being launched out of China, not that that's important, is going to wind up doing proximity operations around a communication satellite. What they did was create this entire scenario in the 2019 timeframe. And we want to actually play this against a catalog of objects, space objects, but the catalog that we have isn't in 2019. So we have a snapshot of a catalog from April of 2018. So we want to take this data and move it into our time frame and see how that plays out. And we can do that using SEG. And just a few things to note about this, if I can see how the graphics are showing up. You'll see there's a pink line here. This is our payload. There's another object here. That's our second stage. And these two are separated quite early in the launch. Our payload reaches GEO, and there's actually a third stage that's dropped off here at GEO. And then I can see this a little better in the 2D view. Just takes a few seconds to re-render this. In the 2D view, we can see our communication satellite sitting there. So the third stage is going to do a flyby. And then the payload is going to do a maneuver and go into a very close cozying up to this, an orbit right next to it. And so we're going to try to reproduce this in SEG. So what I've done is created a scenario in SEG. Let me start off on our scenario page. So we have a list of scenarios here, and I'm looking at this 2019 launch that has been slipped to 2018. This is my scenario that I created. I would hit this open button, and it would take me to my scenario page. And this is the landing page for the scenario, where the center view here is a cesium view, showing all of my tracking objects, all my trackers. And if I scroll out a bit, it's actually showing my all of these geo catalog objects that I've added. And in the database snap that I have about 50 or so geo catalog objects. And I put all of these into my scenario. And so these objects over here, there's a communication satellite, a payload, a second stage, and a third stage. And these all correspond to the objects that came out of SDK. And so just to back up real quick, what I did, if this is going to flip over. No, it's not. For each of these objects in SDK, I started off by exporting the ephemeris. So there's an export ephemeris tool in SDK. And I can use that to export the satellite ephemeris into a .e file. And so once I've done that, what I can do back in SEG is create, so for instance, I create a new object, or I add an event. And when I add the event, it's going to come up. My event inputs are here, and once I add an event, I can go back and edit that event, and that's pretty much what we're doing here. But the same interface shows up whether I'm adding or editing the event. So when I add this event, what I did was gave the event name of payload. I selected the event type as ephemeris, and then there's a file browser here that lets me go and grab a .e file from my file system and load that into SEG. And once I load this ephemeris, it's going to tell me what the actual ephemeris start and stop time is in that .e file. Of course, these dates are in May of 2019, which is not the time frame I want to use. So we have the ability to time slip this ephemeris. And I want to move this ephemeris back, and I want to keep it in a fixed frame. So I want the same relative latitude and longitude in 2018 as I had in 2019. So I moved the first time of this ephemeris point. I just basically kind of grab the times and replace all the times with new times. And that's keeping the Earth fixed frame the same. And so I put in this time slip date. I want the time slip time to be the same as my initial time up here, just to make the math a little easier. And since this is a new object being launched, again, I want to create a new simulated object. And in this case, I'm going to give it a tracking number. I'm just going to use our default tracking number of 90,000, which is for UCTs. So this is a way in our system that any object that doesn't exist in the catalog and that comes in as a UCT, which is an uncorrelated track, we're not sure exactly who it belongs to a priori. But any tracking number or any measurement that has a tag on it with a space object ID of 90,000 or greater is considered to be an uncorrelated track. And that's why we're giving it this number. As far as SEG is concerned, it really doesn't matter what that tracking number is. but downstream for the people processing the data, they're going to care, or they may care about what that number is. So we make up values for what the mass is and what the force model parameters are for drag and solar pressure, so that when we propagate this satellite, the force model will be computed correctly. And finally, down here at the bottom is where we select our sensor cadence. And we have a way to search through the various cadences that have been defined on our system. I selected the one is at high geo, which is just nothing but opticals, and we're getting 8 tracks per day per object. And so I've repeated that with the communication satellite with the second stage and the third stage. And so, again, for each of those objects, I exported the ephemeris from SDK. And for each one of these, I've just pointed this object to use that ephemeris from SDK. But I changed the time frame from 2019 back to 2018. And there's a generate output up here. Once I set my scenario up, I hit generate output, and it takes a minute to run and generate this data. Once it does, I get this visualization updated. So yeah, the other thing I had done was, let me bring this up really quickly, is to add a geo catalog. Because that's kind of the point of this, was to see how do these objects play out against objects that are already up at the geo catalog. Sorry, up at geostationary orbit. So for my geo catalog event, I have a list of the objects that I have already selected, and I can go in and modify that list by adding more. And this is a selector I use to pick which objects I want to incorporate in this catalog event. So I can either type in a space object name, or if I know what a tracking number is, I can type that in. And once I see this object, I could select it and add that into my catalog. So again, this might be related back to the tracking ID question, but if I want to use 25544, if I type that in right, the ISS shows up. And so that is how I created this catalog event. And there are other filters in there too. I actually was able to pick all of my geo satellites just by the orbit class, which is very nice. So just to validate that we are seeing the same type of results that we saw in SDK, I'm going to move our visualization forward here. And again, this is having some rendering slowness on our system. And I'm trying to find our payload and our ComSat. There it is. So if I double click on an object here, what it's going to do is change my viewpoint so I can jump right to that object. And it's going to show some information about that satellite. And then when I move forward, I'll be able to see our payload show up. This is really slow. All right, yes, I apologize. I have not run this as a webinar. So it might be a little unresponsive to keep looking at this view. But okay, well, here we see that there is a payload here. There's our ComSat here. And basically this payload is going to take up residence right next to our communication satellite. So we are seeing the same thing. But what we really haven't shown that much is that, okay, we have objects that are doing their own thing. We have a catalog, but right now they're kind of two separate things going on. So as far as an exercise goes, one could pose the question, what if that third stage was not identified correctly? And this is something we can do natively in SEG, is say, actually I want to take that third stage, and we're going to assume that it maybe isn't really just some inert third stage, but it's actually able to do other activities. And so that third stage is going to wind up doing prox ops around an existing catalog object. And so I've created an event here where I have an existing catalog object, SkyMuster2, which is a Australian communications satellite. And our third stage object, which I've added in a previous event, I can use that to convert that into an actor object in a proximity operations event. And I set up a natural motion circumnavigation where the third stage is going to be orbiting SkyMuster2 in an ellipse. And so instead of trying to see that back in our page here, I'm going to take a look at that. Well, I do want to show how we get to this. So once SEG runs and generates all of this data, it produces a lot of output. One of the things that we can do in SEG is download a VDF. There's a download VDF button. It makes it very easy. Once this VDF downloads, we can just open that in SDK. And since I've already done that, I can just jump over to SDK. Come on. And what we're seeing here, this 41794 is the SkyMuster2 satellite. And this is our third stage. And I'm displaying this. I did a little tweaking here of the VDF. I'm displaying the third stage orbit relative to this satellite and this satellite's VVLH frame. And so that shows very nicely that the third stage is entered into an elliptical orbit relative to this satellite. So that's our natural motion circumnavigation proximity operations event. How are we doing time-wise? Okay. So one other thing I wanted to show, I'm going to do another quick demo, but first I wanted to show, we talked about API documentation. On our user interface, there's help documentation and there's API documentation. So the help page, there's a lot of verbiage written about what SEG is, what it does, how it works, and there's a number of different subjects here that we've written on. I'm not going to go into details about that right now, but just wanted to show that it does exist. And we'll take a look at the API documentation. So all of our services have information about how to use them. There's WSDLs and links to the API doc drilling down into this. So for prox ops, for instance, if we drill down, we can see the services. It jumps to the proximity operations event service. There are a number of services. These are all of our REST services. If I wanted to add proximity operations event and I wanted to know what inputs go into it, I can drill down into precisely what these definitions are. And all of that information is spelled out in our help system. So now I'd like to take a look at one more demonstration. And this is really about training or working with satellite operations to determine. I kind of set up a case here where I want to answer the question, how much tracking data do I need to meet a mission requirement? And I'll see how we do this with SEG. Initially, I set up just a simple catalog of objects, 4 different objects in different orbit regimes. This is taking a little bit to refresh itself. I have screenshots that I have ready to go. I think it might be easier to use that.
Just so everyone knows, this is just because of the GoToWebinar application. It's not usually like this. SEG runs quite smoothly when it's not in presenting mode with GoToWebinar.
Yes, I've never seen it like this.
So we apologize. Thank you for being patient.
I mean, everything seems to be running slowly, which is really weird.
Yeah, I think when there's a lot going on the GoToWebinar,
okay,
it slows everything down a little.
Can I do? All right, so I start off with a catalog of a few objects. Initially, I'm going to have these catalog objects use a very, very dense tracking cadence. So I've defined down here 90 tracks per day. I doubt I'm going to get that. I wouldn't expect to actually get that many tracks from radars. There just aren't that many radars in my system, and I have just not that many tracking opportunities. So when I run and process the data, I'm going to look at the outputs. And when I click on one of these objects, what I'm going to see is that I can drill and look at the measurements that are actually generated for each of my objects. And we'll see here the total number of tracks for this object, 1264, was 25. So that's as many tracks as it was able to come up with. What I want to do then is download these measurements so that I can use them externally. And once I download these, I'm going to process these measurements in ODTK. So let me jump over to my ODTK scenario. So I'm going to jump over to probably the most interesting case here. So you may not be familiar with ODTK, but it's an orbit determination tool that we create. And since SEG is generating observations as well as ephemeris, the observations are really there to be processed in a catalog processing type of workflow. So anyone doing space operations or flight dynamics may be interested in this part of the study. So I download measurements from SEG, and I'm going to add those into my scenario, and I can also download the trackers from the database that SEG is using. I can download those trackers into my ODTK scenario. My satellite state, I can also download ephemeris from SEG and load that into ODTK and use that to create my initial state for my satellite. Then I can create a filter, so I'm actually processing those measurements that SEG produced. And what I'm looking at here is a graph of my measurement residuals versus sigma, or my residual ratios over that filter run. And I have a lot of, again, there's 25 tracks or so here. And most of my residuals are within that plus or minus 3 sigma distribution. Also, when the filter runs, it's going to generate a ephemeris for that satellite what the orbit determination solution was, and also generate a prediction for that, including the covariance for that satellite. And since ODTK is creating that data, I can wind up pulling that into SDK. So I want to start off with this as my baseline, as I have a lot of data, and that generates an ephemeris and a covariance coming out of ODTK. Then I'm going to go back to SEG, and I'm going to rerun my catalog object. I'm going to pick one of these objects and run it using a new cadence, which is only 10 tracks per day. And again, I look at my output measurements from SEG, and I see that I only have 10 tracks. And I'm going to download those, and again, go back to SDK or ODTK. And to just jump to the punchline here, I run the filter for those measurements, and we can see that there's 10 tracks here. There's a big gap on this side. It's just less data. And of course, if you're running the satellite, the less data you have to purchase, the less it's going to cost. But is this enough to really get you where you need to be? So at this point, I want to compare the results of 10 tracks per day to the results of 25 tracks per day. And I do that in SDK by looking at covariance ellipsoids. This is towards the end of my scenario in the predict range. So let me back this up a bit. And the way I got this scenario was, again, by downloading a VDF from SEG. That was my starting point. So I have some trackers that I was using, and I have the satellites that were my initial catalog event, these 4 objects. And I've added 2 more satellites to this, which came out of ODTK. The first one is when I had dense tracking, and that is the white object here, and the blue one is the ODTK result using sparse tracking. And this 41356 object is the SEG-produced ephemeris, which in OD parlance would be considered the truth ephemeris, because that's what I'm trying to match ultimately. If I can scroll in here, I can see that here's the SEG object. Here's the result of ODTK using as much tracking data as I can get. And here's the object at this point in time using the sparse data. And as that moves forward in time, you can see that the dense tracking stays pretty close to the truth. And if I have sparse tracking, it's a little bit different. When I get to the end of the day, it should be back to pretty close because we had some tracks right at the very end. So everything kind of syncs up. Well, not quite there. So they get very close again for a time, and then obviously we don't have the correct velocity quite for the sparse one, so they drift off again. And then at this point, we're doing predictions. We've run out of observations, so we're just propagating the ephemeris and the covariance forward. And so one could use this as trying to determine based on my mission requirements and what my covariance requirements are, how much error I can handle comfortably in my mission, how much tracking data do I need to get. Obviously, we wouldn't do this for one day, but you can do it over many, many days, many runs, and see how it shakes out. I think I've covered everything I wanted to. All right, so as Patton said, you fight like you train, which means you should train like you're going to fight. And to do that, you need a tool that will generate data that's as realistic as possible. And that is our goal with SEG in order to support test training, tactics, and exercise missions. So thank you for listening. And I think we might have some more questions.
If there are other sensors besides the known SSN, can these be added?
Yes, there are services that we have that allow you to enter sensors.
Awesome. And another question, how can I get the data such as numbers and graphs from SEG?
You can download, I think, everything. Depends on what data and graphs you're looking for. But yeah, you can download the PDF, you can download measurements. We have reports that are basically Astrogator summary type reports. And those you can either copy to a clipboard or download those.
Great. And then is SEG an SDK module of its own, or is it its own environment?
So SEG is its own product, its own environment. SEG is runs through services and uses a backend database as data storage. Whereas SDK is a desktop application and uses a file system, uses files as its storage medium. However, data can be downloaded from SEG to be loaded into SDK. And obviously, you can take ephemeris out of SDK and load that directly into SEG as well.
Great. And what observation formats are supported?
We support the B3 observation format.
Great.
Which is discussed in further detail in our ODTK documentation, and I don't know if that's also in our SEG help online as well.
Definitely. And then what measurement types are available?
We support radar, which is azimuth elevation, range, and Doppler. We support right ascension and declination, both ground-based and space-based.
Great. Thank you guys so much. Thank you, Jim, for presenting, and thanks, Ben, for helping out with the question. And thank you all for joining the webinar. For those questions that we didn't get to, we will be answering those individually after we sign off. Make sure to sign up for our next webinar on January 31st on scheduling for space system operations. And just so you guys are all aware, you will be getting this presentation sent in an email to you in the near future. So stay tuned for that. And thank you again. We'll see you next time.